Welcome to solverfy.
We are given a communications network, and we are asked to use Kruskal's algorithm to design this network in an optimum way. So, this network described at the beginning of this section is such that a company plans to build a communications network connecting 5 computer centers in San Francisco, Chicago, New York, Denver, and Atlanta. We're told that any pair of these centers can be linked with a leased telephone line, and we're asked to find which links should be made to ensure that there is a path between any two computer centers so that the total cost of the network is minimized. In other words, we're given a weighted graph, which you can see in Figure 1 of the book, and we're asked to find a minimum spanning tree. And in particular, we are asked to use Kruskal's algorithm to find this minimum spanning tree. So, to begin Kruskal's algorithm, first, we want to draw the graph with the vertices of our given graph and with no edges between the vertices. This is what I have here, just the graph with the vertices San Francisco, Chicago, New York, Denver, and Atlanta. For the next step, I want to find the edge with the smallest weight. So the smallest weight of $700, we see this occurs between cities Chicago and Atlanta. So we add this edge to the graph. I'll draw this in red. And next, we find the smallest weight of the remaining graph is $800, and this is the edge between New York and Atlanta. And so we'll add this edge to our graph. In the next step, we see that the smallest weight of $900 in the remaining graph lies between San Francisco and Denver. So we add this edge to the graph. So San Fran and Denver, $900. In the next step, we see that the smallest weight in the remaining graph is $1,000 and lies between New York and Chicago. So consider adding this edge between New York and Chicago. However, if we were to do this, we notice that we would have a circuit with New York, Chicago, and Atlanta. So we would not obtain a tree. Therefore, we're not going to add this edge as the algorithm dictates. So we're just going to ignore this edge. Now the next smallest weight in the remaining graph is $1,200, which lies between San Francisco and Chicago. If we already add this edge between San Francisco and Chicago, we don't obtain a circuit, so this is perfectly valid. And now notice that we have a connected graph, and so it follows that the algorithm terminates, and by Kruskal's algorithm, the resulting weighted graph is a minimum spanning tree. With edges Chicago, Atlanta, Chicago, San Francisco, San Francisco, Denver, and Atlanta, New York. And so this is the minimum spanning tree with these edges is our answer.